All right, here are the answers to homework number 11, the chapter review. Check them out. All right, let's go through them. I think this first problem, I'm not sure I like it too much, but here's the way I interpret it, which makes it a little difficult. It says Lisa was selling Girl Scout cookies. After 1 week, she had sold 20 boxes. After 3 weeks, she had sold 75 boxes, and after 7 weeks, 100 boxes, and after 10 weeks, 250 boxes. Find the rate of change for cookies sold during weeks 2 through 7. So I interpret that as I want to start with how many cookies she sold at the end of week 1, which is right here. So going into week 2, she had sold 20 boxes. All right, so then she sold some in week 2, week 3, week 4, week 5, week 6, and week 7. And after week 7, she had sold 100 boxes. So to me, that's what we're looking at. We're looking at 80 boxes she sold, right? I know there's no week 2 up here, which makes it seem kind of difficult. But the fact is, during week 2 would be boxes sold starting at the end of week 1, starting after week 1, right? So what I did was I did 100 minus 20, and I counted up the weeks, right? Week 2, 3, 4, 5, 6, and 7. That is 6 weeks worth of selling boxes. Weeks 2 through 7, if you include week 2, would be 6 weeks of selling boxes. So I got 80 over 6, and 80 over 6 turns out to be 13 1/3 boxes per week. Part B, similar. We want weeks 4 through 10. So if you're going to include week 4 as part of your sales, then you want to start after week 3. And after week 3, she had sold 75 boxes. After week 10, 250 boxes. So that is 250 minus 75. And week 4 through 10 would actually be, right, weeks 4, 5, 6, 7, 8, 9, 10, 7 weeks. Technically, you'd be doing 10 minus 3. And you'd get 7 weeks and 175, is that right? 175 divided by 7. That equals 25, and you got to have the units, boxes per week. All right, a little bit controversial, I feel like, but that's how I went with them. Number 2 through 7, we're finding the slope. So here the slope would be y minus y over x minus x, which would be 1 over negative 1, which is 1. Number 3, the slope would be 2 minus 2 over 4 minus 0. That's 0 over 4, which is 0. And in number 4, the slope would be y minus y over x minus x. That's negative 3 over negative 1, which is 3. More slopes. I'm still y minus y over x minus x, which is minus a negative, so it's plus. That is negative 4 over 0, which is undefined. Number 6, I'm going down 1 over 2. That's a slope of negative 1/2. And then number 7, the rise is 3, the run is 1, so the slope is 3 over 1, which is 3. All right, y varies directly with x. Write a direct variation equation. So a direct variation equation is going to be y equals k times x. In this case, k would equal 8 over negative 4 because k equals y over x. And that means it's negative 2. So my equation would be y equals negative 2x. And when x is 7, y would equal negative 2 times 7, which is negative 14. And number 15, the k value would be y over x, which is 2.5. So my equation would be y equals 2.5x. And when x is 7, y would be 2.5 times 7, which is 17.5. Number 10, again, I want to find the k value. K is equal to y over x. So in this case, that would be 3 over 9, or 1/3. So my equation then would be y equals k times x. There's my equation. And when x is equal to 7, y would be equal to 1/3 times 7, which is 7/3. And last up, again, I got to find the k value, which is y over x, negative 4 over 4, which is negative 1. And so my equation for this would be y equals negative 1 times x, or just y equals negative x. And when x is 7, y would be negative 1 times 7, which is negative 7. All right, here I want to see if the table represents direct variation. And if it does, write an equation. Well, you can tell if a table represents direct variation by looking at if every ratio of y to x is equal. In this case, 7.5 over negative 3 equals negative 2.5. Certainly, 2.5 over negative 1 equals negative 2.5. Negative 5 over 2 is negative 2.5. And negative 12.5 over 5 is negative 2.5. Since all the ratios are negative 2.5, then that means, yes, y varies. I don't know why I wrote this out. Y varies directly with x. And the equation would be, this is your k value. So your equation would be y equals negative 2.5 times x. In number 13, okay, it is direct variation if the ratio of every y to x is equal. So when I do here the ratio of y over x, I get 6. But when I do it here, 12 over 5, I get 2.4. Those are not equal, so no, this one is not direct variation. Number 14, we want an equation in point-slope form. So point-slope form looks like this. And I want my line to have a slope of negative 7 and pass through this point. So I simply plug those numbers into point-slope form, and I would get y plus 11 equals negative 7 times x minus 3. Number 15, I need to write an equation in standard form. Well, to write an equation in standard form, I'm first going to have to write it in point-slope form or slope-intercept form. I usually like to do point-slope form. First, I'm going to need the slope, which would be 13 minus 8 over 4 plus 3. So that's going to be 5/7. So my equation in point-slope form would be, I'm going to go ahead and use this point. It'd be y minus 8 equals 5/7 times x plus 3. All right, to change this into standard form, the first thing I'm going to do is I'm going to multiply both sides by the common denominator, 7, to clear out the fractions because standard form does not have any fractions. So over here I get 7y minus 56. On the right side, 7 times 5/7 cancels out the 7, and I get 5x plus 15. Now I want to move the terms around so they're in the right location. The 5x needs to move over to the left side, and the 56 needs to move over to the right side. And I get negative 5x plus 7y equals 71. And then the last thing I need to do is I need to make the x term positive. So I'm going to multiply everything by -1, which simply changes the signs, and I get 5x minus 7y equals negative 71. And now I have an equation in standard form that passes through those 2 points. Number 16, I want an equation in slope-intercept form. Okay, so the first thing I need is the slope. In this case, it would be y minus y over x minus x. That's going to be 0 over -4, or 0. All right, this is an easy one. It's got a slope of 0, so it's a horizontal line. And so the equation is just y equals whatever the y values are. In this case, they're 4. And the slope is 0, so there's no x. You could write y equals 0x plus 4, but no need. In 17, I need to find the slope as well. It'd be y minus y over x minus x, -3 over -3, which is 1. So we could now write the equation in point-slope form, or we could solve for the y-intercept. I think on this one I'll solve for the y-intercept. So I'm going to take this point and this formula, and I'm going to solve for the y-intercept. I'm going to put the 1 in for y. I'm going to put this 1 in for m. I'm going to put the 6 in for x and solve for b. This would be 6 plus b. I would subtract 6 from both sides and get b equals -5. So now I have my slope and my y-intercept, and my equation would be y equals x minus 5. Number 18 and 19 just say write an equation for each line. I think both of them look easy to do in slope-intercept form because I think I can figure out the slope and the y-intercept. In 18, the slope is down 1, right 1. So that's a slope of -1 over 1, or just -1. And the y-intercept is right here, which is also -1. So the equation here would simply be y equals -1x minus 1. Or if you don't like to write the coefficient of -1, be -x minus 1. Number 19, the slope would be a rise of 2 and a run of 3. So the slope is 2/3. And the y-intercept is right here, and that looks like it's at 1. So my equation would be y equals 2/3 x plus 1, once I know the slope and the y-intercept. All right, I'm supposed to graph these. It does not say how to graph them. I'm going to graph them in the easiest way possible. In number 20, I'm going to use the fact that the slope is 4 over 1 and the y-intercept is -3. And I'll go ahead and put a dot at the y-intercept and then go up 4, right 1. Up 4, right 1. And I've got my line. In number 21, this is a horizontal line. I go to y equals 2, because it's y equals 2, and I make a horizontal line. Number 22 is in point-slope form. Here is the point that I know is on the line. That is the point 1, -3. So let's go ahead and put a dot at 1, -3. That point's on the line. And the slope of the line is 2, which tells me to go up 2, right 1. Up 2, right 1, up 2, right 1. That's enough. And there we go. Number 23. Okay, number 23 is in standard form. Probably the easiest way to graph it is to find the x-intercept, which when I cover up the y, I find out the x-intercept is 10 when I put 0 in for y. And when I put 0 in for x, I find out that the y-intercept is 2.5. Well, that is not my favorite way to graph it. I could graph it that way, and I could scale this by 2's and make that 10 and that -10. And the y-intercept would be 2.5. Let's make the y go by 5's. And maybe my line could look like that. And that'd be one way to graph it. Another way to graph it, the way I did it in the answer key at the beginning, was I put it in slope-intercept form. I moved the x to the other side, and then I divided by 4, and so I got a y-intercept of 2.5, and I got a slope of -1/4. In this case, I do not need to scale the graph. I can just go ahead and put the y-intercept at 2.5, and then I can go down 1, right 4, or I can go up 1, left 4, and I get the correct line. In number 24, the easiest way to do this would be to get, again, the x and y intercepts. The x-intercept is going to be at 9, and the y-intercept is going to be at -3. So I'm going to have to scale my x-axis again by 2's, and my y-axis can be by 1's. And I would put a dot at 9 on the x-axis and -3 on the y-axis, and my line might look something like that. In number 25, I've just got x equals -3. That's a vertical line. I go to x equals -3, and I draw a vertical line. Last up, I want to write an equation that passes through the given point and is parallel. It does not tell me what method to use, so I'm going to use the easiest one possible. In 26, I know that this line here has a slope of 5, so my line has a slope of 5. And now I'm going to take my point and my slope and write an equation in point-slope form. It'd be y plus 1 equals 5 times x minus 2. In number 27, again, I have a point and I have a slope, so I could use point-slope form. You know, y minus y1 equals m times x minus x1. And I would plug my -5 in for y, that would be plus 5. And I would plug 9 in for my slope, because lines that are parallel have the same slope. And I would have x minus 0. So, you know, really that's just y plus 5 equals 9x when I distribute the 9. Or if I subtract 5 from both sides, I'd have y equals 9x minus 5, and now I'm in slope-intercept form. Either one is fine. You know, this is fine, this is fine, this is fine. They're all good because it didn't tell us what form to write it in. All right, the next say, determine whether the graphs of the equations are parallel, perpendicular, or neither. All right, so to determine whether things are parallel or perpendicular or neither, I just need to know the slope. This equation is in slope-intercept form. Its slope is 6. This one is not, so first I might subtract 18x from both sides, giving me negative 3y equals 15 minus 18x. Then I would divide by negative 3, and I would get y equals negative 5 plus 6x. And it turns out that the slope of this line is 6. So both slopes are 6. These lines are parallel. Number 29. All right, I need to figure out the slope of the two lines. This one is not in slope-intercept form, so I'm going to go ahead and put it in slope-intercept form by subtracting 2x from both sides. That gives me negative 5y equals negative 2x. And then I'm going to divide by negative 5 and get y equals 2/5 x. So that is a line that is now in slope-intercept form, and its slope is 2/5. Over here, to get this in slope-intercept form, all I need to do is subtract 3 from both sides. And I have y equals 5/2 x minus 3. And the slope of this line is 5/2. So those slopes are reciprocals of each other, but they're not opposite reciprocals. So these lines are not perpendicular, and they're not parallel because they're not the same. This one would be neither. All right, finally, it says, write an equation of the line that passes through the given point and is perpendicular to the graph of the given equation. Unfortunately, I got to put my final answer in standard form. All right, so in this first one, if I'm going to write an equation, the first thing I need is the slope of a line. The slope of this line is negative 3. My line is perpendicular to this one, so my line would have a slope that is the opposite reciprocal. That would be positive 1/3. Now I can use my point and my slope to write an equation in point-slope form. And I would have y minus 5 equals 1/3 times x minus 3. And finally, now that I have the equation, I need to put it in standard form. So again, the first thing I do for standard form is clear the fractions. In this case, that means multiplying both sides by 3. That gives me 3y minus 15 equals 3 times 1/3 cancels out the 3's, and I distribute the 1. 1 times x is x, 1 times 3 is 3. Finally, I want to move the terms so they're in the right spots. The x needs to move over to the left, and the 15 needs to move over to the right. And I would have negative x plus 3y equals 12. So that is not quite standard form, and it's not quite standard form because I need the x term to be positive. So the last thing I would do is I'd multiply everything by negative 1, and that will change the signs. The negative x becomes positive x. The positive 3y becomes negative 3y. And that's going to equal negative 12. And now my equation is in standard form. All right, and finally, number 31. Again, I want an equation for a line that's perpendicular to this one. So that really tells me the slope of my line. This line has a slope of 8. My line is perpendicular to it, so my line is going to be the opposite reciprocal. It's going to be negative 1/8. And now I am ready to write my equation. I'm going to take my slope, and I'm going to take this point, and I'm going to write an equation in point-slope form. It would be y minus 10 equals negative 1/8 times x minus 4. And finally, I need to change it into standard form. So I'm going to clear the fractions. I'm going to move the terms where they belong and make sure the x is positive. First up, clear the fractions. I'm going to multiply both sides by the common denominator, which is 8. Well, this side would be 8 times y and 8 times 10. So I get 8y minus 80. On the right side, when I multiply 8 times 1/8, I cancel out the 8's. And I would just be multiplying negative 1 times x and negative 1 times negative 4, which is positive 4. All right? I have cleared the fractions. Let's move the terms. The 80 needs to move to the other side, so I'm going to add 80. The x needs to move to the other side, so I'm going to add 1x to both sides. And my final result is 1x plus 8y equals 84. And I'm in standard form. All right?